Boker Tov. I'm delighted to be here. I've gotten the sense you've gotten an introduction to recommender systems, but I would like to just see with a rough show of hands, how many people were already familiar with collaborative filtering and recommender systems? Good, so we can skip through a lot of stuff, like how Movie Lens works. Wow, wasn't that exciting? We can get through our matrices. We can talk about the fact that there's this immense set of algorithms that have been out there and applied to this problem, including the mostly dominant matrix factorization techniques today, and jump very quickly to the fact that we then have to measure success. And being in a place where we have a mix of academic researchers and people from industry, I think we recognize that we measure success in typically two different ways. We measure it with sets of metrics, often ones that can be computed offline, things like error metrics, metrics that evaluate precision and recall and top 10 performance or top 5 performance or top 1 performance. We also measure experimentally, as you've heard, with click-through rate and conversion rate and lift on sales and other measures like that. And so starting there, the question is, what's wrong? And the challenge is that many recommender systems, commercial recommender systems, research recommender systems, do really stupid things. And they do them over and over. And so if you take a look at Amazon, this is an old picture. I'll explain what happens in the new picture in a little while. This is our own Movie Lens site, which some of you have seen. This is LL Bean, clothing retailer. They're all making, in this case, the same mistake. Does anybody see what that mistake is?
They assume you want more what you already have.
That's exactly, or almost exactly what they're saying. In fact, every one of these sites showed me the same recommendations the last time I went to the site. I didn't buy those items. And so it said, I know what? Let's recommend them again until you do. Brilliant! I said I would tell you what Amazon does today. For the last 3 weeks, Amazon has showed me almost nothing except 2 product sets. Amazon Echo, which I've bought, but they want me to buy another one. I don't know why. And adjustable desks, which I'm looking for, but I don't need for 2 more months, and I don't want to buy now. But there's no way to tell Amazon, go away for a while. I don't need it. I might need it later. It's just recommending the same thing. So which of the metrics that I showed tells you that your recommender system is showing the same thing again? None of them. In fact, maybe I click on it. Maybe click-through rate will help me detect this. But the metrics are not solving this problem. So what this talk is about is a challenge and an approach. And the challenge is to take the things that I actually know something about. And I'll tell you right now, there are at least 200 people in this room who know data mining algorithms and machine learning better than I do. And there's about 203 people in the room, so that's a pretty good number. But I know user experience. My background is in human-computer interaction. And I view my challenge for the next stage of machine learning as translating user experience into something that other people can write their algorithms to optimize for. Because I'm encountering lots of people who know how to optimize, and very few of them who have any idea what they should be optimizing for. And there's a lot of ways of doing this. There is this pure empirical theoryless experimentation, something that places like Amazon did a lot of. People like Ronnie Kohavi have done a lot of pioneering of massive A/B testing and saying, we're just going to try everything and see what works. And sometimes that works. But I'm going to argue that more often what we want is theory-driven and theory-building exploration. I do a lot of my work with people who are trained in other fields, psychologists, frequently economists at times, other people, who have really good ideas as to what people would value, but don't necessarily have the ability to carry out these massive online experiments. And the sequence that I'm going to work through with them is, let's build the experiments. Let's propose a measure that we think would improve the long-term user experience we care about. And I really mean long-term in many cases. Some of our experiments will follow people 6 months, a year after we make a change, to see if maybe in the short term people liked it and in the long term they left the site. If that happens, we're not very happy, because we don't want something where people click through more often today and leave our site tomorrow. We want something where people are active for the long term. And then where we can, translate those metrics into something that you can create some sort of multi-dimensional tensor factorization model that somehow optimizes. And how you do that's all up to you. Okay, so what are we going to talk about? Let's take some examples and then turn this into a couple of lessons in whatever time we have for discussion. I'm going to start old and I'm going to move newer. So a lot of you weren't there back in the olden days of recommender systems when we stood at the mountain and Moses came down and said, 10 items shall ye rate before ye shall be holy and worthy of receiving recommendations. Just look at it. It's in the book of Recommenders, chapter 6, verse 7 through 15. It's not exactly what it said, but it's close enough. And this came out of the research community because the immediate thing that happened, and those of you who weren't there at the beginning should realize, the first time people working in collaborative filtering got together across different projects, it was done because industry created the hosting environment. It was a company called Infonautics, and it brought together a bunch of different projects from different places and said, we want to apply this. This field never existed without industry. Just didn't matter until industry brought us together and said, this is important. And the industry people came back and said, that's stupid. Why should you make people rate? People don't rate in the supermarket. People buy stuff. People sometimes don't buy stuff. And just use the implicit data. And of course, researchers looked at that and said, but then we don't have ground truth and we can't publish. And we were sad. But somehow research moved forward and we started thinking about, well, how do we get people to give us data without turning them away? And there was a wide range of studies around this, including some that our group did about learning new user preferences and new interfaces for eliciting preferences. And we got some interesting reactions because some of the things we did sounded good and didn't work. So one of the obvious things we tried in the movie domain at that time was to say, well, what if we can predict which movies you've seen and only ask you about the ones that we think you know something about? Wouldn't that be easier? And it turns out we were very good at predicting what movies people had seen. We would give them a list of the most popular movies ever, and they've seen a few of them. And then we would take the movies that highly correlated with those, and they've seen a bunch of those. And as it turned out, we got lots of data, which was bad, because most of the data that we got was highly skewed towards a really badly representative set of their tastes. And all we would keep recommending to them was basically more movies like that small set that was the core that we had gone after, because we didn't probe their tastes. We just dug in. We found out they liked Star Wars. We asked them about all the Star Wars movies, and when we ran out of those, we asked them about science fiction and Star Trek and other things, and never found out they liked romantic comedies set on the beach. And we had a lousy system. The metrics looked good. The time to startup was good. Our initial error rates were good. And our diversity was really bad. We tried other things. We tried user-directed, say, why don't you just tell us which movies you'd like to tell us about? And that had sort of mixed results. It took a long time for people to come up with what movies they wanted to tell us about. It was harder. When you asked people about it, they told you it was faster and that they liked it. even though we measured it on the clock and it was slower. So people don't react to time as if time were moving the way the clock moves. When they're excited and engaged, time moves slowly. I think Einstein said that. It might not have been Einstein, it might have been a psychologist. But you know, time moves slowly when you're having fun, or something like that. Doesn't sound like it's supposed to be time flies, but we get the idea. But it turned out the only problem with that is the recommendations we made people afterwards were a lot worse. Because people also don't explore their whole tastes. Once they thought of something, they went down the same rabbit hole towards things. And so things got challenging. We started thinking about some very different ways to innovate. This took us a while to get to. And we had a very new model where we said, well, what if we don't ask people to rate individual movies? What if we give them sets of movies with some representative tags? If you can't read the text here, you've got, you know, a set of movies about courage and earnest and touching, like Braveheart and Apollo 13 and $1 Million Baby. Down in the bottom right, you have computer game explosion sci-fi like Men in Black, The Matrix, and iRobot. These tags came from users of the system. These movies were assembled by creating clusters based on people's ratings and tags, and then coming up with explanations based on user-contributed content, eliciting preferences for groups, because even if you didn't see all the movies in the group, you probably knew if they were attractive to you or not, and then mapping that back into the space of movie tastes, which we can do either through individual movies or through latent factors in a matrix decomposition. And we did a lot of experimentation, including looking at the question of, you know, what happens in terms of time spent if you ask people to look through certain numbers of clusters and how many they pick, and do they allocate points or do they just pick the clusters? And what came out of this was, wow, it's a lot faster. And people liked it. And that's what we do now. So we changed how we did things because we got a message. It gave us a reason to explore. Things are different. Message 2, or example 2, the filter bubble. How many people here have read or heard about the filter bubble? Just the concept. How many people are worried that their recommender is isolating them into a set of stuff that's different from what other people are seeing? Like they're only getting news they agree with? You know, maybe you're only getting fake news. No, none of us get fake news, right? It's other people who get fake news. I'll tell you what they also say. None of us get fake news. It's other people who get fake news. So this was a big deal. This was a big deal even before certain elections that I'm not planning to talk about. And we wanted to understand what's the role of recommenders. This is a very human question that when I go to Google News or Yahoo News or any of those sites, and they're personalizing my content, what does that do to me? Well, sadly, we don't control those sites, so we did the next best thing, and we said, what happens to people who study or who use recommenders in a domain where we do have a site? In this case, again, movies. Do people narrow their consumption? And that led to some interesting challenges and some interesting results. So first we had to understand, what does it mean to know whether your consumption narrows or not over time? And what does it mean to know if you're being led by recommenders? And so Tien Nguyen, who led this work, did two important things. One came out and said, we have a methodology for testing whether people follow recommendations. Turns out even in MovieLens, a large number of people don't use our recommendations. They use the site, they put in ratings to keep track of things, but we can track every time we've given them a recommendation, and there's a whole bunch of people who never later come back and rate the movies that we suggested. They mostly don't even look at the suggestions pages on the site. They go out and they pick their own movies and they use this to keep track of them. We compared that against people where we showed them a recommendation, and later during a window of time, at least 3 hours later, so we know it's not that they remembered the movie, but no more than 3 months later, so that we think we had some influence on them, they came back and told us what they thought. He also looked at how do we measure whether people are getting broader or narrower tastes, and we did that by looking at content attributes of the movies and looking at the similarity or lack of similarity among the movies people watched at a time in the future. And we found some interesting results. We found that the consumption of movies by topic narrows over time. It narrows over time if you use a recommender. You don't see as broad a set of movies as you saw when you first started. It narrows over time even more if you don't use a recommender. Turns out consumption narrows over time as you learn your tastes, as you figure out that you've used up the broad stuff that everybody likes and now you know what you like. You get narrower and narrower. And the recommender actually broadened people a little bit, but not as much as if they weren't narrowing. That wasn't completely discouraging, it wasn't completely encouraging, and clearly it's not obvious that this is enough to generalize to what happens when people are reading their news from one source or another. Because we were looking at explicit content and not just sources. And if you narrow your sources, different things happen, even if you keep your content slightly more diverse. But it allowed us to understand some human properties that were going on. Two more examples, but first I need to pause for a complaint. Recommender systems have a word in them. It wasn't my word. Paul Resnick gets the credit for coming up with this, of recommendation or recommender. Data mining and machine learning systems largely get evaluated on how well they predict stuff, and particularly how well in studies they predict data that was withheld. So everybody who's done an exercise on building a recommender system has taken a data set. Here are all of the groceries that the person bought. Here are all the movies the person rated. Here are all the books that the person read. Let's take 10 or 20% of them away and train a recommender and see how good a job it does coming up with the 10 or 20% that we hid away. Which is a great exercise in data mining and machine learning, and a completely useless way to evaluate a recommender. Because a recommender that tells you about things that you already knew about, but doesn't tell you about things that you didn't know about that might have been better than the things you already knew about, is sort of useless. And we have this problem in the field that those of us who look at this, all these things are evaluated offline, and we optimize towards discovering things that you already knew. Both the ones that were hidden away and the ones you never told us about but you still already knew. We don't spend a lot of time talking about how do we discover things that are better than you already knew, because the machine learner is trained that what you knew is perfect. It's ground truth. It's unfortunately the same thing we inherited from the information retrieval community that came up with a notion of precision and recall that assumed we knew what all the correct documents were. So it's okay to measure precision and recall because we know what's right. But in real recommender applications, we don't know what's right. When you're recommending groceries, we don't know which ones were correct. We only know that when we try something you've never bought before and you buy it and you decide you like it and you go buy it again. When we're showing you ads, the best ad is not the one you clicked on 5 times before necessarily. It might be the one you've never seen and suddenly you're inspired and you click on it and you purchase that product and you tell your friends about it. But we don't have the measure for that. Okay, that's enough ranting. I feel better. But there are metrics we can build that help with this. And 2 of them are really nice. They're metrics called diversity and serendipity. Different people have defined them in different ways, and in fact, even the definitions to operationalize them are hard. I'm not going to summarize which different definitions people have used. But diversity is usually measured as how different things are from other things. And when people talk about diversity in recommenders, they talk about it two ways. They talk about how different your recommendations are from what you've already consumed. Are they diverse relative to your history? And are they diverse relative to other recommendations? If I put 10 things on the screen, are they different from each other, or are they 10 versions of the same thing? So if I go to Amazon, I'm going to do this because there's nothing more fun than a live demo. But I bet it's here. And if I go to Amazon, and the recommendations that it's giving me are all brackets to hold a computer under my desk, and they are. That's not what was there yesterday. Yesterday it was the desk you attached to those brackets. So I guess that's diverse. If you go down somewhere, they finally took out the desks, and now they're just giving me the brackets. I don't know why. But if I do that, that's not very diverse relative to each other. One bracket would be enough. And then I could get a nice book on the history of the Negev or something, but I didn't get that. Serendipity is a little different. Serendipity has been defined in a number of different ways, but the most common definition starts from the terms delightfully surprising. And it usually involves bringing two things back together. Serendipity is that it's unexpected, but positive. If it's unexpected and you don't like it, they don't call it serendipitous, which creates a challenge because compound definitions are hard to operationalize. But people have done some interesting studies in this space. Kai Ziegler, who visited our group back in the early 2000s, was motivated around the question of diversity. Interestingly, by Amazon in the books department, where he kept getting lots of books by Tolkien because he was a Tolkien fan. But his view was, I've read all of these. There's 80 different editions of the book that I'm not going to buy because I already have read all these books. And why won't it show me something else? And he showed that if you built an algorithm that explicitly threw out things that are too similar to what you were already about to recommend and replaced them with things that were lower down on the list but different, two things happened. One, your individual recommendations were worse, and users knew it. They knew they were less likely to buy the item or like the item that was further down on the list that you promoted. They also thought that the list as a whole was better. And he really experimentally validated the idea that the list is not the same as the combination of the individual items. That you can have a better list with worse items if you introduce diversity, which could lead to a whole discussion on other topics about diversity that we're not going to get into. More recent work by Kapoor and Kumar showed some of the issues about novelty seeking, and I'll come back to that in a minute. We've also found in a number of recent papers that simply giving people control, letting them tune things, pick their algorithm, pick the tuning parameters, do they want more diverse, less diverse, makes people happier, makes people use the systems more, seems to get them to take more recommendations. And there's a lot of value in that. But you still need to understand what's going on inside users' heads. And so we've done a bunch of experiments where we give people control, measure what they do, go back, interrogate them afterwards, usually online interview-style questionnaires. And we found that there's a number of things that we know about these metrics, that in general, this novelty, this idea that people want things that are less popular, isn't true. If you make things less popular, they seem obscure. People feel reassured by things they've heard of. They don't want a recommendation for some Japanese film master whose work has only been subtitled in 3 languages, none of which they speak. Even though it might be a wonderful film, They want a movie they've heard of, but they didn't go see. If you were from the psychology field, you might say they're in the realm of Vygotsky. They want things that are accessible, within their reach, within the zone of proximal recommendation, if that's a term. Well, it is now. But they do want more diversity than typical recommender systems offer them. They want to have choices, real choices, not 6 or 7 of the same thing. There's more work going on along these lines, including work on looking at personality. Raghav Karamur carried out a couple of studies looking at people's big 5 personality types and how they corresponded with both the level of activity and content preferences for users, and found some significant relationships there. We don't know the causation yet. There's more work to be done here. And I mentioned the work that was looking at temporal change in novelty preferences, that in music listening, unlike movies, there are times when people only really want to hear stuff that they've heard before. They want familiar favorites, and there's other times when they want to explore. And we're looking at cues which can help you tell one from the other, because their tastes change, not just their taste in music, but their taste in novelty changes depending on mood and other things. And some of the people doing phenomenal work in context modeling have the opportunity to connect this here. I'm going to give you one last thing that ties to the problem I started with, which is rethinking the idea of top N. This is a paper that was actually presented by Qian Zhao earlier this year. And it challenged 2 assumptions about top N lists for recommendation. One, that we should start at the top. Well, that's sort of obvious, top N. Nobody says what are the middle N, but we're going to challenge that. And 2, that we should go in order from top to bottom. So basically he said maybe the top N list isn't the best thing at all. And I'm going to use some of his slides because he had an interesting visual way of showing this. And what he showed was the experience of coming to the top picks from Movie Lens, and coming back there, and back there. And the only thing you'll notice is that it didn't change. His analogy, which I sort of appreciate because I like a good restaurant, is what would happen if every time you went to this restaurant, the waiter says, "How would you like some French onion soup?" Oh, stop that. And you said, "I don't want French onion soup." "Why do you always recommend French onion soup?" "Well, that's the best thing we have, but I never want it. But it's our best." It just stops. But there's a conflict with the other side of this, which is as you explore further down the list, take a look at your first page of recommendations, your 5th page, your 10th page. If you go too far down the list, things keep getting worse. Imagine what it would be like if this talk started with great excitement, and then it was okay, and by the end it was really, really boring. That would be a lousy talk. I didn't save anything for the end. So his idea, and our idea, was what if we experiment with 2 ideas? Cycling. The idea that we could take things you've been exposed to enough already and demote them. And serpentining. The idea that you shouldn't walk down the list, but you should sort of walk through the list and come back to the high parts again later. So if you start here on the left with 4 items because they fit on the page, but pretend they're 600 or something, and they're sorted in order, but 2 of them you've seen a bunch already, we can move the lower ones up higher in the list. Now we actually did this with sets of 24, and we did this over bigger things. Serpentining is a similar idea. What, instead of showing 2 pages of 4 items each, what if we interleave them? So we show you the, stop that. We show you the odd numbers first, and then we show you the even numbers. And that isn't actually what we did. We just interleaved them over a set of 8 pages, so that you've got some good items on every page, and some not as good items on every page. This is a complex chart. I'm not going to expect you to get all of this. But we wanted to understand what happens if you do this. And these are just the significant results. That one of the things we found was that this cycling behavior, if you do it too quickly, so that within a session you change things, people opted out. On the other hand, both serpentining and cycling got people who stayed around to engage with the site more. They clicked more, they looked at more items. Now, there was also the fact that objectively, the recommendations got worse. There was some confusion that occurred. It's not completely obvious what to do. The one thing that was completely obvious was that mixing the two of them together was way too confusing, and no one had any idea what was going on. So I'm going to pull all this together and then open it for whatever time we have for questions. I hate and love data mining and machine learning. So I hate it because it encourages us to be lazy. People measure what's easy to measure. You know, we know this. Remember, we were really interested in understanding basically how fit or fat people were. And we have techniques to measure the percentage of body fat that you have in your body. But other than elite athletes and people who are health nuts, nobody does that. Somebody computed the body mass index that just said, well, let's just take your height and weight and divide them, and that's good enough. Well, it is sometimes, and some people have big bones. Let's be honest, for me, it's not going to make a difference. It's a big number either way. But for some of you, you realize, oh, if I optimize to that, I'm getting the wrong result. We do this in everything. We did this in recommender systems, where for years we optimized for error, and then we optimized for the top K, and then but we don't necessarily optimize for long-term customer value, because it's hard to measure how long do people stay around, do they tell their friends, do they do referral business. So instead we got clicks. Clicks are good, right? And those of you who were in the business of selling clicks remember the panic in the industry when people started saying, I'm not sure I want to pay for 1,000 impressions, and I'm not even sure I want to pay for clicks. I only want to pay for clicks that result in something. That's not good. We're good at selling 1,000 impressions. We can count clicks. We don't know if they like your product when we're done. Yeah, but that's what mattered. So we get lazy. And the easier it is to solve the wrong problem, the more we do it. On the other hand, I love data mining and machine learning. I spent the first 7 or 8 years of work in recommender systems doing algorithms, because we couldn't solve the problems we wanted to without inventing algorithms. You know, the last algorithms that I published pretty much were the algorithms that dealt with matrix factorization techniques. They were the item-item algorithm followed by some papers on SVD techniques. And then the field just magically got better for me. There were people like my colleague George Carabas, whose picture is here, who are really, really good at data mining. And for the last almost 15 years, every time I've had a problem in recommender systems and I said, here's what I want to do, I could sit down with him and he would say, oh, there's a way we can learn that from the data. And if I would just give him the function to optimize, I don't have to do any computing. He'll make the computing happen. That's what I imagine most of you are, the people who make that happen. So the challenge, I guess, for all of us is, if we know algorithms don't figure out the right problem to solve, and that to figure out the right problem, we need to study people. We need a bridge. I'm proposing that for many of us, that bridge may be metrics, the thing you optimize. That if people like me can figure out something that people like you can use as a target, then we can go from studies through metrics to algorithms. And of course, we won't be done, because when all that happens, the people are going to change, their expectations are changing, and I'll go run more studies and we can keep tuning this. But I think we have a hope of actually making recommender systems and data mining generally something that actually solves the problems we care about. Thank you, and I would love to take your questions. We have mics going around. If you can't get one to you, I'll repeat questions, but it'd be great if you can get one.
How do you see the contribution of reinforcement learning in this topic? Like, the main problem is that it's hard to simulate what would happen if you would recommend this or other, because you don't know a priori the responses to the customer. But if you use reinforcement learning, you might learn it while you go in production.
Yeah, so the question is about reinforcement learning. I have seen examples that seem really promising there. I think that systems that are using the feedback live to tune things are fundamentally a good idea. I worry, again, that the challenge is mostly reinforcement learning is geared towards short-term results. And so is it important, if you're selling ads, is it important that somebody clicks on them? Yes. Is that the only thing you should be optimizing for? No. And if we have learning systems that the only input they have is the short-term value, because it takes too long to measure and cycle the long-term value in, sometimes it would be better to have a different kind of metric, including pop-up surveys, including other things that are there that might do a better job. But in general, I think the technique has a lot of merit. I just think we have to be cautious not to use it in a way that overemphasizes something that we know is not the most important outcome.
Any more?
Thank you.